Our first problem requires us to use our arithmetic skills. But I don't think that there is enough leverages of ambiguity in this problem to cause us to make too many mistakes. The square operation and the division operation take precedence over addition. We will therefore carry them out first. Besides, there is no other initial step that makes any sense under the circumstances. So, in solving this problem, we may divide 2.76 by 0.8 and also square 8.7. Then we will add the result. So there we have the result of 2.76 divided by 0.8 and the square of 8.7. Finally, we will add those results, and the result is 79.14. The annual salary is equal to 12 times the monthly salary. We were given the monthly salary and we are required to determine the annual salary. Take that, multiply by 12, we have the annual salary, there's nothing to it. To find the commission, we need to multiply his sales by the rate that is given as a percentage. His commission is 2% of his sales. Therefore, in order to find his commission, we need to take the amount of his sales for the entire period concerned and multiply that by the percentage that is given. The percentage that is given is 2%. 2% is actually 2 divided by 100, turns out to be 0.02. We need to take 720,000 multiplied by 0.02, and that is equal to $14,400. His total income for the year is equal to the sum of his fixed salary and his commission. So in order to determine his total income, we will add the annual salary to the commission that he accumulated throughout the year, and that is equal to $52,080. Here we have the ingredients for making 8 pancakes. In order to make 8 pancakes, we have 2 cups of pancake mix. We have 1 1/3 cups of milk. So 2 cups of pancake mix and 1 1/3 cups of milk. That will make 8 pancakes. Therefore, if we want to make 16 pancakes, we will have to have 4 cups of pancake mix and 1 1/3 times 2, which is 2 2/3 cups of milk. So we are dealing right here with proportions, and throughout the solution of this problem we will be making use of proportions, the right proportion all of the time. And I especially appreciate this problem because some students might not be aware, or the general public or the lay person may not be too much concerned with the amount of mathematics that is used on a daily basis. Sometimes in the home we are required to do a few things, maybe in cooking or in washing. We have to use in cooking the ingredients in proportion, and also in washing we may make use of the detergents also in proportion. So a problem that is based on proportion, we cannot overemphasize the importance of it. And it is a very good thing that we are causing it to have very intimate, as I would put it, intimate application in our everyday life. Ryan wants to make 12 pancakes. It is obvious that since 12 is equal to 1.5 multiplied by 8, he needs to use 1.5 times the amount of pancake mix. Now he wants to make 12 pancakes. Be aware that 8 pancakes, 2 cups of pancake mix, 1.5 cups of milk. So the ingredients that we have here is strictly for 8 pancakes. But he wants to make 12 pancakes, and we need to determine the amount of pancake mix that he needs to use. So Ryan wants to make 12 pancakes. It is obvious that since 12 is equal to 1.5 multiplied by 8, he needs to use 1.5 times the amount of pancake mix. So we are dealing with proportion. What do we multiply 8 by in order to get 12? We multiply 8 by 1.5 and the result is 12. Therefore, we need to multiply the cups of pancake mix by 1.5 also. And if we are talking about the cups of milk, we need to multiply 1 1/3 by 1.5, which is 1.5 also. So we are going in proportion all of the time. And how did we arrive at this 1.5? Well, let us work that one out first. So we need 1.5 times the number of pancake mix, and that is 1.5 multiplied by 2 is equal to 3. We may take the approach in which we take the number of pancakes that he needs 12, and divide that by the number of pancake mix, or the amount in each batch of ingredients. Then multiply by the number of cups of pancake mix in the ingredients. So in order to determine the relationship between the number of pancakes that Ryan wants to make and the number of pancakes in the ingredients, we divide the number of pancakes that he needs to make by the number of pancakes in the ingredients. So that is 12 over 8. That result will be multiplied by the number of cups of pancake mix that we have in the ingredients, and we will end up with the same figure, 3. Nisha used 5 cups of milk. We first need to know how many. Nisha used 5 cups of milk. We first need to know how many batches of the ingredients that 5 cup represents. The number of cups in each batch is 1 1/3. And 1 1/3 is equal to 4 over 3 if we convert that to an improper fraction. We first need to divide 5 by 4 over 3, which is basically a little bit more than a mouthful. But Nisha used 5 cups of milk. That 5 cups of milk, how many batches does that represent? So we are trying to find a relationship between the number of cups of milk that Nisha used and the number of cups of milk in the ingredients. When we work that out, that should give us the number of batches of the ingredients that 5 cups represent. Then we will take that number and multiply by 8, and we will be able to tell the number of pancakes overall. Dividing by a fraction is the same as multiplying by its reciprocal, and of course 4 into 8 is 2, 2 5 10 times 3 is 30. Therefore, the number of pancakes is equal to 30. So let us take a second look at that. Nisha used 5 cups of milk, and we need to determine how many pancakes will the 5 cups of milk represent. In order to do that, we need to find out by establishing a relationship with these 5 cups of milk and the number of cups in each batch. So in order to determine the number of batches of the ingredients that the 5 cups of milk represent, we will have to divide the 5 cups of milk by 1 1/3 in order to determine the number of batches that 5 cups represent. Then, after determining the number of batches, we multiply by the number of pancakes in each batch, which is 8, and that will tell us the number of pancakes overall. And this, we might just call it simple proportion. For me, it is not simple. It requires a bit of mental energy and numerical skills. And sometimes we see people turning out to be great chefs, executive chefs, and we think that in terms of mathematics they might be a little on the downside. When we have problems like these to solve and realize how prone we are to making errors with these problems, then we will have a greater appreciation of those folk. Here we have A is equal to 6, B is equal to -4, C is equal to 8, and we need to determine what the result will be if we substitute those values in the expression that we have there. And as usual, our first step is to make a template. Templates are very good because they have the capacity to capture the negative sign in order that we will not neglect them to our demise. So there we have our algebraic expression. Let us create a template that emulates it. So there is our template. And what do? Where we see A, we put A, or the value of A. Where we see B, we put the value of B, we put the value of B. Because we have 2 occurrences of B. And where we see C, we put the value of C. Then we will simplify. Square 6, we get 36, and we have a -4 right there. And 8 minus -4 is equal to 12. And that is one purpose of also giving us a negative value. Maybe because we have a positive sign here, we'll just go straight ahead and add 4 and make a meal of the problem. Or here, we'll just put a single negative sign because we have a -4. But if we can use a template, we'll see that we need to subtract a -4, and any error that we have the tendency to make is nullified. The fraction may be reduced by a common factor of 4. 4 into 32 is 8, and 4 into 12 is 3. There we have an expression in which we need to simplify. Expand the brackets and combine the like terms. Begin by expanding the brackets. The expression that we have right there, we need to simplify that expression. We will begin the simplification process by expanding the bracket. So 3 times x is 3x. 3 times negative y is negative 3y. Four times x is 4x. 4 multiplied by 2y is 8y. Then we will put the like terms together by saying 3x plus 4x is equal to 7x, and negative 3y plus 8y is equal to 5y. And that is all there is to it. We also need to simplify that algebraic expression, which is comprised of algebraic terms and also a particular letter or symbol with indices. A very good first step is to reduce the fraction by a common factor of 3. But let us simplify the numerator first by multiplying the coefficients. So 4 3s, 12. Next, according to the laws of indices, when we multiply numbers with the same base, we add the indices. Again, we will divide by 3x cubed. First, reduce the coefficients by a common factor of 3. 3 into 12 is 4, no problem with that. When dividing expressions with the same base, subtract the index of the divisor from the index of the dividend. So 6 minus 3, and the result is 3. So we will have 4x to the 3, or 4x to the power of 3, 4x cubed as our answer. Solve that inequality. Begin by placing the x's on the right hand side and the constants on the left hand side. Negative 3 here, negative 7 here, transposed to be a positive 7, and also this positive x here, we will have a negative x. So we have 7 minus 3 is equal to 4, and 3x minus x is equal to 2x. Then we will divide the inequality by 2, eliminating x from the right hand side, and on the left hand side we have 4 divided by 2, which is 2. We need to turn the inequality around. It is always good to have that x, which is our proposed subject, on the left hand side. In so doing, the inequality sign needs to be changed also. And that is a simple logical reasoning. As we always say, if my brother is younger than I am, then I am older than my brother. So x is greater than 2. Integers are numbers that are not accompanied by a fractional part. The next number that does not have a fractional part that is greater than 2 is 3. There's no difficulty with that one. So the next number that is greater than 2 is 3. which will be the smallest number that satisfies that inequality. First, let us show the universal set that contains whole numbers from 1 to 12. That is our universal set. It contains numbers from 1 to 12. Then we have T is the set of multiples of 3. We will have that T, the set of multiples of 3. E is the set of even numbers. No problem. Let us put our diagram up and insert our elements in their respective places. When completing a Venn diagram, it is appropriate to place the elements common to both sets first. So those that are in the intersection will go first, the ones that are common to T and E. So 6 is our first, the other one is 12. Next, we have the unique elements of T, 3, or the rest of T, followed by the unique elements of E. Those elements that are unique to E will go next. Finish up with the elements that are in the universal set but not in any of T nor U. So there we have the elements that are in the universal set but not in any of T or E, which of course will be all of those elements that we have in the universal set that we do not have inside of here already. And finish up with 11. Next, we need to find T intersection E, the elements common to T and E. They are 6 and 12. The intersection of the two sets is the set of elements that are shared between them, the elements that they have in common. 6 and 12. T union E all complement. What does T union E all complement mean? The union of two sets is the set of all of the elements of the two sets combined. The complement of the union is the set of elements outside of the union. So the complement of any set is the set of elements that are not in that set. So we have the complement of the union, all of the elements that are not inside of the union. So we block all of the elements that are inside of the union, and what we see are all of the elements that are not inside of the union. And we have T union E all complement is equal to 1, 5, 7, 11. An interesting statement. Combination of sets are also sets and must be enclosed in brackets like any other set. If we are writing the elements of a set, if we are writing the combination like T intersection E, that is a set. T union E, all complement, that is another set. Therefore, we need to enclose them in braces as we have here. And the same way that we enclose any other set, like the universal set, or the set of the elements of T, or the set of the elements of E, enclosed in those braces. Right. So the combination of sets are sets and also need to be enclosed in brackets as we have them right here. The construction problem that will be solved on the next slide is simpler than it appears. Constructing a triangle to given specifications is not hard. However, there are geometric implications that are coded into the information that simplifies the process that may be used in constructing it. So it is not difficult or impossible to construct a triangle to given specifications. However, in this particular problem, there are information that we have that are coded. We have implications, geometric implications that are coded into the information that is given to us. And if we know those implications, then the construction may be simplified. There we have the one that we are required to reproduce. The triangle has two angles that are equal to 60 degrees. What is the size of the other? We have a triangle with two angles that are equal to 60 degrees. What is the size of the other? The sum of angles in a triangle is equal to 180 degrees. Subtract those two from 180 degrees and we get 60 degrees. Did not need to go through all of this process. We are sure, we know already that if two angles of a triangle are equal to 60 degrees, then the other one must also be 60 degrees. So all of the angles will be 60 degrees then. This is not rocket science. If two of the angles of a triangle are equal to 60 degrees, then the other one has to be equal to 60 degrees. With all of the angles of a triangle being equal, the triangle is equilateral and all of its sides are equal. So in any triangle that all of the angles are equal, it is an equilateral triangle. All of the sides are equal. The triangle may be constructed by drawing the line AC, which is 6 centimeters. After opening the compass, the full length of the line, place the compass point at A and make an arc. Then place it at C and make another arc to cross the first one. So if we open the compass to the length of the line that we have there, which is 6 centimeters, we open it to the full length of the line. If we put it at one end and make an arc, put it at the other end, make an arc to cross the first one, it means that we would have constructed an equilateral triangle with all sides equal to 6 centimeters. As long as it is equilateral, all angles will be equal to 60 degrees. No matter what the length of each side is, as long as it is equilateral, all angles will be equal to 60 degrees. Now the one that we will use is draw AC is equal to 6 centimeters and construct a 60 degrees angle at A. Draw AB equals 6 centimeters, then complete the triangle. Do not forget that the basis on which we constructed a 60 degrees angle is that an equilateral triangle has 3 equal angles of 60 degrees each. So what we will do, we will draw the first line 6 centimeters, construct the 60 degrees, draw the other line 6 centimeters. So we will have what? 6 centimeters on one, 6 centimeters separated by 60 degrees. Then the other side will automatically be 6 centimeters and the other angle will therefore be 60 degrees. In completing the construction, which is to complete the kite, because we know that we are eventually constructing a kite. In completing the construction, we may use the special feature of a kite in simplifying the problem. The diagonals of a kite are perpendicular to each other. Also, the one that is a line of symmetry, because for a kite, one of the diagonals will cut the kite into two halves that are mirror images of each other. So one of the diagonals is a line of symmetry of the kite, while the other is not. So the diagonals of a kite are perpendicular to each other. Also, the one that is a line of symmetry of the figure will bisect the other one. So one is a line of symmetry of the kite and it will bisect the other diagonal. The line of symmetry will bisect the angle B and the line segment AC. So the diagonal of the kite will bisect B and bisect the line AC. With AC is equal to 6 centimeters, the line of symmetry should be drawn 3 centimeters from each end. We are not doing any measurement now. We'll do that when we are actually doing the construction. After drawing that line, by sliding your ruler, locate the point D that is on the line of symmetry and is 5 centimeters from A. It will also be 5 centimeters away from B because it is on the line of symmetry. After drawing this line, slide your ruler and get this line that is 5 centimeters away from A. So it is, that point is 5 centimeters from A and is on this line. Because this is a line of symmetry of the figure, when we locate the point 5 centimeters from A, it will also be 5 centimeters from C. There are two such points. I am referring to the one below the line AC. So we're going to have 2 points on this diagram that will be 5 centimeters from A and C. One will be located about there and the other one will be located down there. For the figure to be a kite, we will have to have the 5 centimeters away from A down here, and it will be 5 centimeters from C. So the one that we are talking about is the one that is below the line. Another way that the point D could have been located is to open the compass to 5 centimeters. Then, by placing its point alternatively at A and C, make arcs below the line AC that intersect each other. So one way we could have completed, one other way we could have completed the kite is to open the compass to 5 centimeters, place the point here, make an arc down here. Place it over here, make another arc. Where those two arcs cross, we just complete the kite using that point. So that's another option. If one chooses to go through more problems than what we will be demonstrating, then as long as the constructs are correct, no loss of marks will be incurred. It will only be a waste of time and effort. However, I am not taking shortcuts, and the construct can be accurately completed with that little effort. I have already demonstrated the geometrical facts that I will be using in order to simplify my work. Let us begin. Construct the triangle ABC. What do we do first? First, draw the line AC is equal to 6 centimeters. AC is 6 centimeters. The angle BAC is 60 degrees. The middle letter is always the vertex at which the angle is located. We will construct the 60 degrees at A by using our usual construct, which is place the compass point at A and make an arc as shown. One there and another there. Remove the compass point to the point of intersection of the arc and the line AC and make another arc like that. Now that line AB is equal to 6 centimeters, the one that will pass through the point of intersection of the two arcs. Draw that to be 6 centimeters. Now, what do we have? We have from here to here is 6 centimeters, from here to here is 6 centimeters. This angle is 60 degrees. When we are through, just by completing the triangle, it is sure to be equilateral. So there we have our equilateral triangle. complete the kite ABCD. Remember what to do. Just measure from A to C, half of that, because we know that is 6 already, half of 6 is 3. So complete the kite, draw the bisector of AC, 3 centimeters from A, so it is 3 centimeters right there. Then what do we do? Draw the line that represents the bisector going through the vertex B. So we are sure that that line is a bisector of B, a bisector of AC, and is a line of symmetry of this figure that we have right there, and also a line of symmetry of the kite. Along the perpendicular bisector, locate the point D such that AD is 5 centimeters. Use our ruler, 5 centimeters located right here. Right. All we need to do is just complete the kite and our work is done. That is how simple it can be. We did not take any shortcut at all. We just made use of certain hidden facts that we have in that figure. Measure the angle DAC. The center of the protractor should be at A, and the line AC is the zero line. So the line AC is the zero line. The angle DAC, start from 0, 0, 10, 20, 30, 40. And angle DAC turns out to be 52 degrees. Here we have a lovely setup in which we need to find the value of this angle and also the length of this side. After working with mathematics for a few years, it should not be very difficult to look at this situation and determine what this is and also what this angle is. In finding x, we will make use of the right angled triangle that is on the right. X is the hypotenuse of a right angled triangle of which the other two sides are known. Pythagoras' theorem may be used in calculating it. That's not difficult. We have two sides of a right angled triangle. The hypotenuse is unknown. Pythagoras' theorem, that's all there is to it. 6 squared is 36 and 8 squared is 64. 64 plus 36 is 100. Square root of 100 is 10. So 10 centimeters. For the other right angled triangle, what do we know? We are putting information on that diagram with the focus on the unknown angle theta. So theta is our angle of reference, and we are saying that this side that we have is opposite to that angle, irrespective of which angle we use as the reference. The hypotenuse will be the longest side and will be opposite to the right angle. The adjacent is going to be this one that is beside the angle theta. The angle theta is a part of the right angle triangle with the hypotenuse is equal to 12 and the side opposite to it is 6 centimeters. Opposite and hypotenuse implies the sine trig ratio. So if we have the opposite and the hypotenuse, the trig ratio that makes use of opposite and hypotenuse is the sine trig ratio. We will make use of that one. And sine is equal to opposite over hypotenuse. The opposite is 6, the hypotenuse is 12. No doubt we'll see that sine theta is equal to 0.5. 0.5, we have the sine of the angle, we need the angle. In order to determine the angle, what do? find the inverse sine of 0.5 or the sine inverse of 0.5. We have the sine of the angle, we need the angle. We do the opposite of the sine, which is finding the sine inverse. That turns out to be 30 degrees. We could have taken a glance at the problem and figure out the two answers. The sides of the first right angle triangle are in the ratio 3 to 4 to 5. The most popular type of right angle triangle, we call it the 3-4-5 right angle triangle. It is the most popular type of right angle triangle. The values in that ratio are multiplied by 2. Notice that what we have here is what? 2 multiplied by 3 is 6, which is this side. 2 4 is 8, this side. And 2 5 is 10, that one. So if we could recognize early that for that particular right angle triangle, the sides are in the ratio 3, 4, 5, then it doesn't take much for us to determine that the other side is actually 10 centimeters. But while one side is 6 and the other is 8, they will have to be the two short sides of the right angle triangle. If they are not, then we cannot come to that conclusion that the other side has to be 10. So the two short sides will have to be 6 and 8. Like we have the two short side will be in reference to 3 and 4. Therefore, the longest side will be in reference to 5. So 3 twos 6, 4 twos 8, and 5 twos 10. For the other one, also, in any right angled triangle in which one side is half of the hypotenuse, the other angles are 30 degrees and 60 degrees. So in any right angled triangle that you can find on the face of the earth, if you can find that one side is half of the hypotenuse, that means we have the other two angles are 30 degrees and 60 degrees. Therefore, the 6 centimeters will be, in this particular case, opposite to the 30 degrees. And we are saying in here that also in any right angle triangle in which one side is half of the hypotenuse, the other angles are 30 degrees and 60 degrees. The half side is always opposite to the 30 degrees angle. So the half side, what do we mean by the half side? The side that is half of the hypotenuse. That one will be opposite to the 30 degrees angle. We are making use of a particular map, and we have measured the distance on the map to be 7.8 centimeters. So for this part of the problem, the actual distance between the points S and F as measured on the map is 7.8 centimeters. The scale is 1 to 1,250. To find the actual distance that the distance represents, we need to multiply the distance measured by 1,250 multiplied by 1,250. So 7.8 multiplied by 1,250, 7.8 centimeters. The answer that we would get for this would be in centimeters. But with no change of unit, the product will still be in centimeters. 100 centimeters is equal to 1 meter. To convert the distance from centimeters to meter, we need to divide by 100. Divide by 100, 97.5 meters. So when we multiply 7.8 by 1,250, we have 7.8 centimeters multiplied by 1,250. The result will be also in centimeters. However, we need the corresponding, or the actual distance that the distance on the map represents, and we need to divide by 100 in order that we will get that answer in meters. Average speed is equal to total distance divided by total time. Total distance is in meters and the total time is in seconds. The speed in meters per second may be found without much difficulty. We have distance in meters, time in seconds. We need speed in meters per second. We just divide. So we have speed is equal to distance divided by time. So we just go straight ahead. 97.5 divided by 9.72, and we get something that is very, very close to 10 meters per second. Now we need also to convert the speed given in meters per second to kilometers per hour. What do we know? In converting, we may take this 10 meters per second and make a conversion. I think it is less sophisticated if we go back to the original calculation. So divide the distance by the time. So go back to the original calculation. In order to convert the meters to kilometers, we need to divide by how many meters make a kilometer? 1,000. And seconds to hours, we divide by 3,600. So we are working in kilometers per hour. Convert this to kilometer by dividing by 1,000. Convert this to hour by dividing by 3,600. Do not forget that dividing by a fraction is equivalent to multiplying by its inverse. So we'll invert that fraction that we are dividing by and multiply. Good. At the end, this is approximately 10. So we'll just remove all of these zeros and the result is 36. So that is 36 kilometers per hour. And I'm delighted to know that. It is good to know that 10 meters per second is actually 36 kilometers per hour. We may find this relationship useful. This means that Bolt is running a bit faster than 36 kilometers per hour. He's actually running close to 38 kilometers per hour. For the most part, in Richard James Mathematics Resources, we have used a particular formula in determining the equation of a straight line. On this occasion, we will make use of the general form. So there's a formula that we always use. Not very often that we use the general form in determining the equation of a straight line. We will do that on this occasion. So y is equal to mx plus c. The line passes through the point 4, 1 and has gradient 3 over 5. Here we will substitute m is the value of m, x is the value of x, and y is the value of y. So substitute 1 for y, 3 over 5 for the gradient, and 4 for x into that equation, and that is what we have. And I'm realizing that in recent years we are required more and more by the CSEC CSEC examiners to manipulate fractions. The fraction has a denominator of 5. Rewrite the whole number as a fraction with that same denominator. So Richard James Mathematics Resources will make very useful approaches in simplifying expressions that contain fractions, so that we do not have to be always demonstrating that we are taking the common denominator, we just go straight ahead and make use of common denominators like that. So we have, instead of 1, we have 5 over 5. Of course, 5 divided by 5 is equal to 1. So 5 over 5 is 1, but we have it with a denominator of 5, which is the same denominator that we have here, making the calculation or the combination of the two fractions, when necessary, very simple. So C is equal to negative 7 over 5. We will substitute those into the original equation. So the equation is y is equal to mx plus c. We already know the value of m and c. All that we need to do is substitute them into the equation. So m is 3 over 5 and c is negative 7 over 5. So y is equal to 3 over 5x minus 7 over 5. Finally, we had to manipulate fractions. We use the strategy of converting the whole number to a fraction with the same denominator as the fraction. In primary school, we learned how to add fractions with the same denominator. At this stage, we need to know how to make fractions with the same denominator. Taking it a step further, our first part, our duty in solving this problem, is to draw the triangle with the given vertices. What do? We have A is 2, 3. 2 units in the x direction and 3 units in the y direction. So 2 in the x, 3 in the y. Plot the point A right there. Then for B, 5 units in the y direction, followed by 3 units in the x direction. C, 3 units in the x direction, followed by 6 units in the y direction. Complete the triangle. That's all there is to it. Then what do? We need to reflect that triangle in the line y is equal to 2. In order to do that, we need to first draw the line or recognize the line y is equal to 2. It is a horizontal line that goes across where y is equal to 2, like so. There are two properties between a point and its image. The line joining a point to its image is perpendicular to the mirror line. So the line joining a point to its image is perpendicular to the mirror line. The mirror line is horizontal. We may therefore make use of the vertical lines of the grid because horizontal and vertical are perpendicular to each other. So, in order to locate the image of A, it is to be located in such a way that the line that goes from A to the image of A is perpendicular to this line. Therefore, it has to be located on this line because this line is perpendicular to this line. Also for C, it is located on this line, which is perpendicular to this line, because the line that goes from an object to its image is perpendicular to the mirror line. A point and its image, that is the second one, are equal distance from the mirror line. So let us show the distance between each point and the mirror line and use that distance to locate the distance of its image on the opposite side of the mirror line. the distance between A and the mirror line is equal to the distance between the mirror line and A prime. Therefore, we have already established that the image has to be on this line because the line joining a point and its image is perpendicular to the mirror line. Also, the image of A from the mirror line is equal to the distance of A from the mirror line, and we will show that on the next slide. So there we have the distance A from the mirror line. A is 1 unit from the mirror line. Its image is also 1 unit from the mirror line, but on the opposite side. That's the image of A. B is also 1 unit from the mirror line. Its image is also located 1 unit from the mirror line on the opposite side of the mirror line, and there we will have B prime. What about C? How many units this time? A little bit more. C is 4 units from the mirror line. Its image will be 4 units away from the mirror line on the opposite side. There is no rule that says that an object cannot cross through the axis. So there we have the image of triangle ABC after a reflection in the line y is equal to 2. Be prepared to use the simplicity afforded by the grid in solving transformation problems. Proceed without mathematical instruments as much as possible. So when we are required to do transformations on the grid, we should progress without using mathematical instruments as much as possible. Most of the times, our spatial skills that are required in CSEC examination, especially when we have transformations given to us on the grid, we are sure that for the most part, we do not have to put a single instrument on it. We may just use our spatial skills and arrive at the answer, because for the most part, you will never hear or see, for that matter, in any instruction pertaining to a problem in CSEC, you will not see any instruction saying using a ruler, a compass, a protractor, and all of this to arrive at any image. You'll just be told, locate the images of A, B, and C under a reflection in the line y is equal to 2, and no details of the process is given, or the required process that you need to go through it will be given, so you may make use of your spatial skills and the simplicity afforded by the grid. Let us plot the points, because we need to draw another triangle. A double prime, B double prime, C double prime. We need to have another, or to draw another triangle. That one. So A double prime is negative 7, 4. So 7 units in the negative x direction, 4 units in the positive y direction. And for B prime, we have what? 4 units in the negative x direction, and then 4 units in the positive y direction. Finally, we have C double prime with what? 6 units in the negative x direction, 7 units in the positive y direction. And complete the triangle. That's what we have. The image is actually the same as the original. It is congruent to the original. Like in most transformation, we have congruence between the image and the object. But in this particular case, what do we know? it is exactly the same, only that it is at another location. When it is exactly the same, only at another location, the transformation is a translation. So there we have, and it matches perfectly. So we see that the original and the image match perfectly. The transformation is a translation that needs a vector to completely describe it. The vector represents the translation of each point. So we are sure that we have a translation and we need a vector to completely describe it. And the vector will be the movement of each point. So 9 units in the negative x direction. From A, we go 9 units in the negative x direction and 1 unit in the positive y direction. The transformation is a translation by the vector negative 9, 1. So we go 9 units. We are looking at A. It will be the same for C. If we do that, if we make the attempt on C, we will get the same vector. So we have 9 units in the negative y direction and we have 1 unit in the positive y direction. Transformation is a translation by the vector negative 9, 1. The vector of translation is a vector that is added to the position vector of the point that is being transformed. The sum will be the position vector of the point. We are making use of calculation rather than the grid in arriving at our answer. So the original point, which is A, 2, 3, plus the vector of transformation or translation, and that will give us the image of A. So it's just a matter of transposition. We have V is equal to negative 7, 4 minus 2, 3. Do our little calculation and we have V is equal to negative 9, 1. So from an arithmetic standpoint, that is the answer that we would have obtained, which is the same as the one that we would have obtained from the grid. Statistics. One very efficient way of organizing a frequency table from raw data is to tally values in their respective classes. 21, 11, 3, 1 to 5, 22, 21 to 25, 6, 6 to 10, 32, 31 to 35, 18, 26, 26 to 30, 16, 16 to 20, 17, 16 to 20. Right. It is good if we could have something like this in the examination, that when we are required to tally, we just fold our arms and it goes straight ahead and tally for us. And a fifth item is represented by a diagonal stroke that completes the group of 5. A fifth item is represented by a diagonal stroke that completes the group of 5. We have that already, and we have another diagonal stroke. We continue on and on until we are through. But what do we know? One of the items of data was mistakenly left out. But because of the habit of striking out the ones that are already included, it is easily identified and may be included. So 34, that is the one that was left out. We see that it is easily identified because it is the only one that was not crossed out. So the habit of crossing out the ones that we use already will help us to locate the one that was left out. Right. Match tally items with frequencies and confirm the ones that are already there. So 1, 2, 3, we are sure that, and then that is 6, no problem, and then we will put the others in. 7, 3, 2, 1. Next, we will construct a histogram to represent the data. A histogram is constructed by plotting the frequencies against the lower and upper boundaries of the class interval of the distances. So we will use the lower and upper boundaries, but those we will have to calculate from what we have here, and these that we have in this column are the class limits. Before attempting to construct the histogram, we will therefore demonstrate how the class boundaries are constructed for the class limits given in the original table. Before attempting to construct the histogram, we will demonstrate how the class boundaries are constructed from the class limits given in the original table. So let us go to the boundaries. A histogram is a bar graph that is used to represent continuous data. As such, consecutive bars must be joined. If the first bar begins at 1 and ends at 5, and the second begins at 6 and ends at 10, the bars will not be joined because the number that is 5 that ends the first bar is not equal to the number 6 that begins the second bar. So if we should just draw the histogram based on this, the histogram is used to represent continuous data because the data is continuous, which is the intention always in constructing a histogram, a representation of continuous data. The consecutive bars of a histogram must be joined, but if we use 1 to 5 and the other one begins 6 to 10, then the bars will not be joined because 5 is not equal to 6. We need to find a common boundary that will be shared by the first and second bars. The number most logically should be halfway between 5 and 6. Here we have 5 and 6, halfway between 5 and 6. Obviously, that is 5.5. But we may calculate the result. 5 plus 6 divided by 2, 5.5, which is the average of the two. And if we go down to the other bars, then what do we know? The second bar should be joined to the third bar. 10 plus 11 divided by 2, that is equal to 10.5, and those will be the boundaries associated with the other bars that are required to be joined. Then we may make another step. The third bar is slated to end at 15 and the fourth bar to begin at 16. The shared boundary will be 15 plus 16 divided by 2, which is equal to 15.5. We may use the fact that each subsequent item may be found by adding 5 to the previous one in order to complete the table. We have 5, 10, 15, 5, 10, 15. So we will just continue those sequences to the end. The lower class boundary of the first class is missing. If we count the lower class boundaries, say 15.5, 10.5, 5.5, going down by 5. The next one is 5.5 minus 5 is 0.5. We may go straight ahead and construct the histogram. In constructing the histogram, the first bar will begin at 0.5 and end at 5.5, and its height will be 1. Then we have First bar, we have that completed already. The second bar will go from 5.5 to 10.5, and the height of that bar will be to 5.5 to 10.5 up to 2, like that. The third bar will begin at 10.5, end at 15.5, and its height will be 4. Then, no information for that fourth bar. Begins at 5, begins at 15.5, ends at 20.5, and its height is 6. Then the 7 bar, 20.5 to 25.5, coming back down. 25.5 to 35.5, the height is 3. Then we have another 2 bar, 30.5 to 40.5. Finally, the last bar, 40.5 to 45.5, and the height of that bar is 1. There we have our histogram. Those who traveled a distance recorded as 26 kilometers or more are those who traveled 26 to 40 kilometers. Recorded, that is the operative term. Recorded as 26 kilometers or more. If we want recorded values, we go to the table. And 26 or more, 26 begins in this row, so 3 plus 2 plus 1, and that is equal to 6. The mode is the best statistical average to use. This is because it represents the distance from the school area where most of the students are concentrated. The PTA should consider where the vast majority of the students are living. And the vast majority of students, the area in which those students are living, that will represent the mode. And that is why, or that will be represented by the mode. And that is why we need to use the mode as the best statistical average under the circumstances. In answering part C, we should consider the phrase distance recorded as. That is very important. Recorded as. In considering that phrase, we are compelled to go to the original table. The original table alone contains distances as they are recorded. The lower class boundaries and the upper class boundaries are calculated or deduced values. So we need to go back to the original table. Some candidates may want to use the graph, and some may want to use a table that is derived from the original table. That is not going to be good enough for distance recorded. So we need to go to the original table for that. Here we have a graph, and we are required to use that graph in answering number 7. The value of f of x where x is equal to 0, that is what we need to determine. So the value of f of x where x is equal to 0 may be found by considering that x is equal to 0 on the y-axis, or that the equation of the y-axis is x equals 0. In order to determine where on the curve x is equal to 0, we may make use of the information that x is equal to 0 on the y-axis, or that the equation of the y-axis is x is equal to 0. Therefore, we are talking specifically of the point where the curve crosses the y-axis, and that is where y is equal to 3, or f of x is equal to 3. The particular x value is 0, so we may safely write f of 0, which is the value of x in that particular case, f of 0 is equal to 3. The values of x where f of x is equal to 0 are those points where f of x crosses the x-axis, where the curve crosses the x-axis. What are those points? There and there. So where it crosses the x-axis is where f of x is equal to 0, so x is equal to negative 3 and x is equal to 0.5. The maximum is the highest point. Its coordinates is the position relative to the axis. So the highest point on the curve is the maximum, and its coordinates are its position relative to the axis. So relative to the x-axis we have negative 1.25, and we have here about 6.1. So the coordinates of the maximum point are negative 1.25 and 6.1. The axis of symmetry is that vertical line that divides the curve into halves that are mirror images of each other. That line that divides the curve into halves that are mirror images of each other. It also coincides with the extreme point on the curve, which in this particular case is a maximum point. It coincides with the extreme point, which is a maximum point in this particular case. Its equation has the general form x is equal to k, where k is some constant, and so also for every line that is vertical. So every vertical line has equation x is equal to some constant. In this particular case, the value of x is right here, so negative 1.25. So x is equal to negative 1.25, and that is the equation of the axis of symmetry. In order to determine the values of x for which f of x is equal to 5, we will first draw the line f of x is equal to 5. Draw that line first. F of x is equal to 5. Y is equal to 5. That's the line. So in order to determine the values of x for which f of x is equal to 5, we really need to draw the line where f of x is equal to 5 or y is equal to 5 everywhere along that horizontal line. Take note of the x values where the line crosses the curve. What are those x values? Those x values are negative 2 and negative 0.5. Those are the points, or the x values of the points where the line y is equal to 5 crosses f of x. The specified region of the curve is above the line. That region is between the values of x is equal to negative 2.5 and x is equal to negative 0.5. So the specified region of the curve, which is above that line, is in the region between the values of x is equal to negative 2.5 and x is equal to negative 0.5. In that region, the region that is above the line, right there. Therefore, in order to represent that, we may say the set of x such that negative 2.5 is less than x is less than negative 0.5. This is saying that x is between negative 2.5 and negative 0.5. Do not be tempted to place negative 0.5 first, because of the numerical value. Because one may be looking at this and saying 0.5 is less than 2.5, place the negative 0.5 on this side. So do not be tempted to place negative 0.5 first because of its numerical value. Negative 2.5 appears larger than negative 0.5. Remember that negative 2.5 is to the left of negative 0.5 on the number line, which is in this particular case the x-axis, and is therefore smaller. So negative 2.5 is to the left of negative 0.5 and is therefore less than negative 0.5. Our beautiful problem number 8. I'm saying it's beautiful because it is always beautiful, or a beautiful requirement of us when we are required to think outside of the hexagon, outside of the box. And we are required to make use of the patterns that we have right here, and also consequences of those patterns that are given to us in tabular form. We started with one hexagon, and the hexagon has 6 sides. For the next hexagon that is added, one of its sides coincides with the other hexagon that is there already. Therefore, we are making use of 5 additional sticks. So when we have a hexagon and we need to put another hexagon beside it, we are making use of this stick that is there already. So we are not using 6 additional sticks, we are using 5 additional sticks. So we have 6 plus 5 is equal to 11, and then 11 plus 5 is equal to 16. The values of x and y will follow the trend. So there is a trend that we need to follow. So if we have 6 plus 5 is 11, and 11 plus 5 is 16, then what about x? X is 16 plus 5, which is equal to 21. And what about y? Y is 21 plus 5, which is equal to 26. Lovely. Then what about z? Let us take a look at the consequences. Let us take a look at the synthesis of the consecutive numbers of sticks used to form each pattern. 6. So we have 6. 11 is 6 plus 5. 16 is 6 plus 10. 21 is 6 plus 15. Notice that we are adding 5, then 10, then 15. After the first pattern, we keep adding a multiple of 5 to the original number. So we have 6 here. Then what we add in order to get 11? 6 plus 5 ones. 6 plus 5 twos. 6 plus 5 threes. Lovely. So we notice that we are adding a multiple of 5 each time. Notice that the number of 5s that are added to the 6, the original number of sticks, of course we are saying 6 is the original number of sticks, so notice that the number of 5 that are added to 6, which is the original number of sticks, is always 1 less than the number of hexagons. So for 2 hexagons we have what? 1 multiplied by 5. For 3 hexagons we have what? 2 multiplied by 5. For 4 hexagons we have 3 multiplied by 5. Now, when the number of hexagon is 20, the number of 5s that will be added to 6 has to be 1 less than 20. Which is 19. To 6, we will add 19 items. So let us take a look at that again. For 2 hexagon is 1 multiplied by 5. 3 hexagons, 2 multiplied by 5. For 4 hexagons, we are adding 3 multiplied by 5. Therefore, the number of 5s that we are adding each time is 1 less than the number of hexagons. But do not forget that we always have to have 6. So now, when the number of hexagon is 20, the number of 5s that we will be adding to 6 has to be 1 less than 20, which is 19. To 6, we will add 19 times 5. Therefore, the number of sticks associated with 20 hexagons is given by Z is equal to 6 plus 19 times 5. So 1 less than the number of hexagons. 6 plus 19 times 5. And there's another way to work it out, but I am using a mathematical principle that at a higher level will prove to be beneficial, and we will see what principle we are using on the next slide. The method that we made use of in finding the value of Z on the previous slide is based on the principle of an arithmetic progression or sequence called an AP. It makes use of a first term and a constant value that is successively added in order to form each subsequent term. So the arithmetic progression makes use of a first term, then a constant value that is successively added in order to form each subsequent term. We have discovered that the first number is 6, denoted by A, which is the first term. A is equal to 6, the first term. And the number that is added to 6 successively is 5, and that is called the common difference, denoted by D. So we have 6. So 6 plus the difference will be equal to 11. And 11 plus the difference is equal to 16. Then 16 plus the difference. Then 16 plus the difference is equal to 21. Let us rewrite each term by adding to the first term, which is A. We're going to be adding to the first term, 6, which is A, to a particular multiple of the common difference. So let us rewrite each term by adding to the first term a particular multiple of the common difference. So 6, and this is what, 11 plus 5, and 16 is 6 plus 5 plus 5, and 21 is 6 plus 5 plus 5. So 6, and then we have what? 11 is 6 plus 1 times 5, 16 is 6 plus 2 times 5, 21 is 6 plus 3 times 5. As noted on the previous slide, the number that we multiply 5, the common difference by, is always 1 less than the number of hexagons. If the number of hexagons is n, the number that we multiply 5 by is 1 less than n. That number is n minus 1. So notice that is 6. 6 plus 1 times 5. For the third, 6 plus 2 times 5. For the fourth, 6 plus 3 times 5. Therefore, for the second hexagon, we add 1 times 5. For the third, we add 2 times 5. For the fourth, we add 3 times 5. What do we know? That for the nth hexagon, we will add 5 n minus 1 times. So for each term, we begin with the first term, which is 6. Then, to that first term, we will add the product of 1 less than the number of hexagons, and 5, which is the common difference. So we have 6 plus n minus 1 times 5. And that is a general rule for the nth term, or when the number of hexagon is n. The answer that we have on the previous slide is not the same in appearance as the one that we have in the answer booklet. It's kind of different in appearance from the one that we have on the answer booklet. Let us take a look at the terms and see if there is any obvious rule that we may use in writing down a general representation of the nth term. And we have this as a reminder of the one that we use just now, which is different from the one that we have in the answer booklet. So we have what? 6, 11, 16, 21, 26. The terms are going up by 5 each time. This means that each term is related to a multiple of 5. So in any sequence that you have the terms going up by a particular value, whether it is 18, 25 or 106, if it goes up by 106 each time, then it is related to a multiple of 106. This one is going up by 5 each time, it is related to a multiple of 5. Right, so we have this 6 is related to a multiple of 5, the 11 is related to a multiple of 5, the 16 is related to a multiple of 5, the 4th, which is 21, is related to a multiple of 5. They are related to a multiple of 5 in the same way. The numbers are 5, 10, 15, 20, 25, as we can see if we work these out. Each one is 1 less than the corresponding term. Notice that this 5 is 1 less than 6. 10 is 1 less than 11. 15 is 1 less than 16. 20 is 1 less than 21. So we need to add 1 to each of them in order for them to be exactly as we have right here. So we have 1 5 plus 1, 2 5s plus 1, 3 5s plus 1, 4 5s plus 1. Then what do you imagine we will have if we have n hexagon? The same is true for the nth term. Multiply n by 5 and add 1. N times 5 plus 1, which is 5n plus 1. Now take the previous expression, which is the one that we have up here, that looks nothing like the one that we have here, 5n plus 1. So s is equal to 6 plus n minus 1 times 5. And if we expand that bracket, what do we have? S is equal to 6 plus 5n minus 5, and 6 minus 5 is 1. So we have S is equal to 1 plus 5n. I'm sure you may see already that it is 5n plus 1, but turn it around. 5n plus 1, and we are sure that both expressions are actually the same, irrespective of how we arrive at them. So I am sure that at this level we might be required to use the process that we have right here. So the one that we have right here may be more applicable at this level, because at this level we are merely looking at more patterns than anything else. But I'm introducing to you the components of the arithmetic progression in order that at the higher level it will not be too difficult for you. It is not going to be difficult for you if it is introduced to you for the first time at that level, but so that at this level you can have some familiarity with it and also see how it is related to simple sequences and series that we might be able to use our common sense to work out. The expressions are equal, they are only different in appearance, as we have discovered. Now, Bianca used 76 sticks to make a pattern that contained 8 hexagons, and we need to determine the value of h. Let us make use of the simpler formula that relates the number of sticks with the number of hexagons. Bianca uses 76 sticks. So S is 76 and the number of hexagons we do not know. So let us substitute 76 for the number of sticks and S for the number of hexagon, which we have here to be n. So we will replace n with h and s with 76. Solving for h, 76 minus 1 is 75. Then 75 divided by 5. What do we know? We may now eliminate 5 by dividing by 5 on the left hand side, and h is equal to 15. The problems that are set as number 8 are more than just puzzles. The ones that especially have to do with a sequence or any other number pattern, those are usually at the foundation of the more advanced work in mathematics. Candidates should keep them and their solutions for future reference.